this video, we're going to talk about logarithms. And before we start talking about it, I just want to say why we actually use it. And the reason why we use it is sometimes we can have some weird stuff going on in powers. For example, let's say we have 2 to the power of x equals 7. Now, based on what we know from math and based on what we talked about before about powers, we know that 2 to some power means that 2 times 2 um, for that many time gives us a number. For example, 2 to the second power equals 4. Now, what power of x, what power of 2 would give us 7? How would we figure that out? Well, the easiest way to figure it out is by using logarithms. And that's when we actually use logs, and that's how we can use logs to help us solve this problem. Now, when we talk about this, I would need to write it in a way that would that that would help us solve it. That's why we're going to use logs. Now, when we use logs, the way we write it is log of we're going to have two elements to our log. We're going to have a base and we're going to have an argument. This is a base and this is our argument. And it's always equal to a certain number. Now, in this case, we have log of, 2 to the power of x equals 7. How can we write it as a log? Now, the easiest way is to write it as log. Our base is the same base that we have in our power, which is 2. And our argument is whatever the power and the number is equal to, which means 7 equals x. Now, the way I learned it in high school was they would draw these pointers to basically point, and they would call it a circle because it goes like a circle. And you basically have your base argument and then you have your answer, which is x. Now, how would we solve this? Because log 2 of 7 equals x, we don't know how to basically figure that out. That's why we're going to use our calculators to figure this number out. And most of the time when you're using logs, you use it because you want to solve something that's kind of complicated like this. And if you don't have a calculator, you will never know the answer for this question. So if you use your calculator, you would get the answer for this question. Okay, here are some rules about logarithm. And the first one that we have is the product rule, which says that the log of a and m times n is equal to log of a of m plus log of a of n. As you can see, since these two are multiplying, when we're trying to basically use this rule, those two products become a plus sign and we basically split both of them up. The quotient rule is log of a, m divided by n is equal to log of a m, log a of m minus log a of n. And there's another rule that's really important that you might use sometimes to just solve some tricky questions. It's log of a of m equals to log of bm divided by log ba. Now we're gonna use some examples to basically do some examples to use all these product rules, quotient rule, and the other rule. But I just want to make sure that you guys know that you might not use the last rule as much as you do these ones. And when you're trying to memorize it, just memorize these two. And again, don't memorize it. Just know that when they're multiplying, it means that there's a plus sign in between, and when they're dividing each other, there's a minus sign in between. For our first examples, we have 2 to the x power equals 20. And this looks like the first example that I showed you guys when I was introducing logarithm. So the way we solve it is, again, we use the log function and we use that circle method, which means this is gonna be my base, that's my argument, and then x is whatever the log is equal to. So it's gonna be log base 2, and our argument is 20. equals x. And if we want to find the value of x, most of the time the teachers don't want you to find it because they don't allow calculators in a class, meaning that if you have an exam or something, they don't want you to use a calculator, but the value of x is equal to log 2 of 20. Now, for the second one, as you can see, it looks a bit complicated, but we can work it out. So we have 2 to the x power equals to, now I have to make the bases for both sides of the equation equal to each other. This number is 8. We already have a problem that we did in one of my videos about this type of question. When we're trying to basically make the bases equal to each other, we have to turn that 8 into a 2. So I'm just going to write a 2 in here. However, now I have to figure out how many times do I multiply 2 by itself to give me 8. And the answer is 3, because 2 times 2 is 4, 4 times 2 is 8. Now that's going to become 2 to the third power. However, we have more of that power, which is 2x minus 5. So 2x minus 5. Now, since our bases are equal to each other, our power should also be equal to each other, which means this x is equal to this whole equation. So x is equal to 3 times 2 is 6x minus 5 times 3 is 15. Now we can move this over here, or we can move that over here. X minus 6x equals negative 15. Now that's going to give me negative 5x, negative 15. Our answer is equal to 3, which means the value of x in here is equal to 3. Now, as you can see, for this example, we have 2 to the x power is equal to 7 2x minus 5 to that power. Okay, for our third example, as you can see, we have 2 to the x power is equal to 7 2x, 7 to the power of 2x minus 5. And as you can see, no matter what we do, we cannot make 7 equal to 2, which means we cannot make the bases equal to each other. This is when we actually use our log function. Based on what we know, log, our base is 2, our argument is 7 to the 2x minus 5 power equals to x, which is the power of 2. Now, how can we go from here? What can we do? There's another hidden rule in logs, and that is the fact that whenever you have a power in your argument, you can bring that power over here, and that would basically multiply your log, which means I'm going to bring that power over here. That'll give me 2x minus 5 log times log of 7, log 2 of 7 equals x. And these are multiplying each other. Now, how can we figure out the value of x? That's easy. We're just gonna divide both sides by Now, since we're trying to figure out the value of x itself, we have to distribute that log of 7, log of 2 of 7, and then figure out what the value of x is. Now, if we distribute that, that's going to be log 2 of 7 minus 5 log. Now, since we only want the value of x, we're just going to move this x into the left side of our equation and move negative 5 log 2 of 7 in the right side of the equation. Now this is going to be a number, which means it's just a number that's multiplying 2. Let's say it's 1. We're just assuming that it's 1. it's just gonna be times 1 minus x. And if we basically use the same operations that we used before, it's just gonna be x is equal to 5 log of 2 of 7. Now, this is not the exact answer for this question. However, if you use your calculator, you should get the values for log base of 2 of 7 and figure out the exact answer. However, this is the way that you can do it, and the most important thing that you should learn from this part of this question is that whenever you have a power in your argument, you can basically bring it up on the left side of your log, and that number or that power would be multiplying your log. Now let's say we have another example. Log there's no base x plus 5 equals 2 log there's no base of x minus 1. Now when there's no base in your log, you should know that there's always a base of 10 here, which means the bases are equal to each other. Log the base is 10. Now when the bases are the same, you can set your exponents or your arguments equal to each other, not your exponents. Your arguments equal to each other. However, you should also account for the number that's in front of your log, because that's basically the power of your argument. As you can see, there's no number in here. It's only 1, which means it's just gonna be itself. However, as you can see, we have a 2 in here, and based on the rule that I talked about before, we know that that 2 is the power of this argument, which means this is x minus 1 squared. Now, how do we solve for x from here? We know that this is just x minus 1 multiplying itself two times, so it's just gonna be, we can just expand that, and we know that's x squared negative x, and that's positive 1. That's x squared minus 2x plus 1. Yeah, and you can also use shortcuts, but I just wanted to distribute it and show you guys how we can figure that out. It's x squared minus 2x plus 1. Now, since we're trying to figure out the value of x, I'm just going to bring everything over here and set everything equal to 0. X squared negative x negative 2x plus 1 minus 5. And as you can see, this is just a quadratic where you can use the quadratic equation to figure it out, or you can just use the mental thing when we do the one that tells us that we have to find two numbers that multiply to 4 that add up to negative 3. And those two numbers are negative 4 and 1, which means our answers are x is equal to positive 4 and x is equal to negative 1. Now, which one is the correct answer? The correct answer should be the one that gives us a positive argument. Now, this is a very easier example. And as you can see, we have log 5 of 2x minus 3 equals 2. How can we figure this out? We know that the argument is always the answer for our exponent. So we know that this is actually 5 to the second power equals to 2x minus 3. Now this actually goes like that circle. As you can see, it's just 5 to the second power equals to that number. Now 5 squared is equal to 25 equals to 2x minus 3. Now we just need to figure out what the value of x is. As you can see, the value of x is equal to 14. Okay, for our last example, we have log base 10 of x plus 6 equals 1 minus log base 10 of x plus 3. I'm just going to write down those tens until you get used to it. Now, how can we solve this? First, we need to bring all the logs in one side of the equation. And as you can see, these two are adding each other up, which means we need to think about the rules that we had. And in the beginning of the video, I showed you all the rules, which means they are multiplying each other. X plus 6 times x plus 3. Now, you need to be careful when you're writing it like this because the bases should be equal to each other, which in this case they are because both of them are 10. Now we need to distribute these two and multiply them. That's going to give us x squared plus 3x plus 6x plus 18 equals 1. Now it's going to be log x squared plus 9x plus 18 equals 1. Now how can we go from here? We already know that the base is 10, so we know that this is actually 10 to the first power equals x squared plus 9x plus 18. All we need to do is bring that 10 over here. That's gonna give us x squared plus 9x plus 18 minus 10. Now we need to figure out two numbers that multiply to 8 but give us 9 when we add them up, and those two numbers are 8 and 1. X plus 8 and x plus 1. Now our answers, possible answers, is -8 and x is equal to -1. Now if we put both of these numbers over here, you can see that since -8 gives us a negative argument, we should know that this is not correct. So the only possible answer is x is equal to -1. And in just a moment, I will tell you why the answers cannot be negative, why the arguments cannot be negative. This is our log graph, or logarithmic graph. And the most important thing that you should know about this is that all the x values that we have is positive. That's why our arguments always needs to be positive. Like, for example, 2 to some power, it can be between 0 and infinity. Or any real number, which means like -1, -2. When we do that, we're going to get 1 over 2 to the second power if it's to the -2, which means all these numbers that we're going to raise it to, it's just going to change the position of that number. If it's a negative, it's going to be in the denominator, and it's going to be 1 to the 4th, 1 over 4, which again is always a positive number. That's why our logarithmic function, the arguments should always equal a positive number, or our argument should always be positive. And it's obvious when you're looking at the graph because you can see that every single x value that we have in this graph is equal to a positive number. And later, I will make a video about the most important graphs that you would know, and logarithmic graphs is one of them. So if you want to make sure that you know it, you can just copy it down right now, and it's going to make it a lot more easier later. Thank you.